Hello, in this video I'm going to talk you through how to find the area of a sector. So before we start finding areas, I want to talk through first of all a little bit of terminology. So if we look at these two pictures that I've got at the top here, a radius, hopefully you already know, is a straight line going from the centre of a circle to the edge. And if I take a circle and I draw two radii on it, the area I will have enclosed is a sector. Okay, so it's like a slice of circle. Sectors are the shape you're going for when you try and cut a piece of cake. Okay, so a sector is a slice of circle. This one here, this smaller sector, we call the minor sector. This one on the outside that looks a bit like Pac-Man, okay, this is the major sector. Okay, so the bigger one or the smaller one. Two other bits of terminology that we don't need for the moment, but just to help you distinguish between the two. A chord is a straight line that goes from one point on the circumference to another. So it does not have to go through the center, and therefore it wouldn't be a radius. Okay, it goes from one point on the circumference to the other. A segment, okay, is the shape that you get when you enclose the area between the chord and part of the arc length, part of the circumference. Okay, so that area there is a segment, not a sector. Okay, so today we're only dealing with sectors. So we know for sure that the two straight lines are radii, which is going to help us do the working out. So first of all, in order to do these questions, we have to be able to answer the question, what fraction of the circle have we been given to look at? So I'm going to go through two examples and then I'm going to give you a few of those to do on your own. So looking at this one here, I've got 45 degrees out of the whole circle. Hopefully you know that all the way around a circle is 360 degrees. So we have got 45 degrees out of the full 360. And I'm going to write that as a fraction. I have 45 out of 360. And I'm then going to simplify my fraction. Now, you can divide this fraction top and bottom by 5, and you can also divide this fraction top and bottom by 9. It doesn't matter which order you do it in, as long as you make sure you keep going until you can't divide down anymore, simplifying the fractions. So I can divide top and bottom by 9. So if I divide the top by 9, I get 5. 36 divided by 9 is 4, so 360 divided by 9 is 40. I can now divide both of these by 5, so I get 1 over 8, 1/8 of a circle. So this sector here, if I'd drawn it accurately, would be exactly 1/8 of the whole circle. Okay. Next one, slightly more complicated. I've got 105 degrees out of the full 360, so I'm going to write 105 out of 360, and then I'm going to simplify it down. Both of these can be divided by 5. Both of them can also be divided by 3. So I'm going to start by dividing by 3. How do I know straight away, just by looking at it, that 105 can be divided by 3? The quick trick, if you don't know it, is you add each of the digits together. 1 plus 0 plus 5 is 6. If your answer is in the 3 times table, then your original number is also in the 3 times table. So because 6 is in the 3 times table, 105 is also in the 3 times table. Okay, so I'm going to do 105 divided by 3. 3's into 1 don't go. 3's into 10 go 3 times, remainder 1. 3's into 15 go 5. Okay, so I've got a 35 on the top. And now I've got to do 360 divided by 3. Again, I know it divides because 3 plus 6 plus 0 is 9. 9's in the 3 times table. So 36 divided by 3 is 12. So 360 divided by 3 is 120. So I've now got 35 out of 120. That can be divided by 5 top and bottom. 35 divided by 5 is 7. Now 120 divided by 5 is 24. But a little trick to use if you find dividing by 5 difficult, you can divide by 10 and then double it. So 120 divided by 10 is 12, and then double it to get 24. That's just a little trick I like to use when I have to divide by 5. Okay, so what I'd like you to do first of all, I've got a few questions for you to have a go at, where what you have to do is come up with a fraction and then simplify your fraction. Okay, so have a look at these ones. You want to pause the video for a minute. We've got these 4 questions first of all, where you've been given a picture, and then these ones here, where you've been given it as a description. Okay, and you need to come up with the angle instead, so it's a little bit more of a challenge. Okay, so I'm going to go through the answers now. So for the first one, this angle here is 90 degrees. So you can either do it by writing 90 out of 360 and then simplifying it. But some of you might know straight away just by looking that 90 is 1/4 of a circle. Okay, but you can do it by simplifying. Question number 2, we've got 72 degrees out of 360. Both of those divided by 9. 72 divided by 9 is 8. 360 divided by 9. Well, 36 divided by 9 is 4. So 360 divided by 9 is 40. Both of them divide by 8, and we get 1/5. So 72 is 1/5 of 360, so it's 1/5 of a circle. Next one, 120 out of 360. Well, I can start by dividing by 10. 12 over 36. I can now divide top and bottom by 12 and get 1/3. So 120 degrees is 1/3 of a full turn. Okay. Next one, 144 over 360. Well, I can half them both, okay, to get 72 over 180. I can half them both again to get 36 out of 90. I can half them both again to get 18 out of 45. Those two numbers are both in the 9 times table. So if I divide by 9, I'm going to get 2/5. Okay, so 2/5 of a full turn is 144 degrees. Right, next up, we're going to find these fractions of a full turn. Okay, so 1/6 of a full turn, 1/6 of 360 degrees is going to be 1/6 times 360, or in other words, 360 divided by 6. And the answer to that is 60 degrees. So if you have a 60-degree sector, you know you've got 1/6 of a circle. To work out 3/8, and this one I'm going to do with a full method, and then I'm just going to tell you the answers to the other two. I can find 1/8, and then I can times it by 3. So 1/8 of 360, I can get by doing 360 divided by 8. That comes out as 45. And then if I want 3/8 of 360, I need to take that number and I need to times it by 3. So I'm going to get out 135 for that one. Okay, so that one's 135. Okay, for 4/9 of a circle, I divide by 9 and then times by 4. So 360 divided by 9 is 40, times 4 is 160. And then last of all, 1/360th of a circle, I need to divide by 360. So 360 degrees divided by 360 is 1. So 1 degree for the answer there. Okay. So once you've learned how to find a fraction as to express what fraction of the circle you've got, you're halfway there to finding the area of a sector. So the area of a sector is a fraction of the area of a circle. Now in maths, when we see the word of, we're frequently thinking times. If you want a fraction of something, you're doing that fraction times that thing. So of, think times. The area of a circle is something hopefully you already know a little bit about. To find the area of a circle, you do pi r squared, pi times the radius squared. Okay, so all you're going to be doing to find the area of the sector is use the fraction that you found, and you're going to times that by pi r squared. I'm going to go through 3 examples for you here, and then I'm going to give you some questions to do. If you have a calculator with you, you can use that for your questions as well. I'm going to go through the full process without a calculator, simplify as far as I can, and then I'm going to get my calculator out for an answer to 3 significant figures. The reason I'm doing that is this can come up in a non-calculated GCSE. So you might as well practice doing this as far as you can without going to the calculator first, if you can do that. Okay, so first question, we have been asked to find the area of this shaded in sector here. I've got this angle here of 90 degrees on the outside, so this bit inside has to be 270 degrees. So I'm going to do 270 over 360 times pi r squared. Now, 270 over 360 can be simplified. You can either doing it using a step-by-step process like I showed earlier, or some of you might be happy just looking at that and knowing it's 3/4. Okay, so 270 over 360 simplifies down to 3/4. Now, r in this case is the 6. Remember earlier on we said that radius was the straight edge going into the middle. So I know I've got 6 as my radius. So 6 squared, or 6 times 6 is 36. Times that by pi, we get 36 pi. Now, my suggestion for timesing these together would be to write the 36 pi as 36 pi over 1. So we've got a fraction times a fraction. And I'm now going to use a multiplying fraction skill that, again, hopefully you've already seen, which is cross-simplifying. I notice, looking at this, that my 36 can be divided by 4, and so can this on the bottom. So something from the top and something from the bottom that can both be divided. 36 divided by 4 is 9. 4 divided by 4 is 1. So I'm going to think of this sum as 3 over 1 times 9 pi over 1. And then I just times across the top and times across the bottom like I'm multiplying fractions. So 3 times 9 pi is 27 pi. 1 times 1 is 1. So I've got 27 pi over 1, or 27 pi. And that's my area. Now, I did all of that without going to a calculator. So this is the type of question that could come up in a non-calculator paper. And if they give it to you in a non-calculator paper, they're testing sectors, but they're also testing your ability to work with fractions. Okay, so that's why it's important to be able to do one without a calculator. If you did do it and found the actual value, you should have got out 84.8. Okay, and you can just check that you can get that out on your calculator, either by typing in 27 over 360 times 36 pi, or 3/4 times 36 pi, or 0.75 times 36 pi, or you can type this in. So just make sure that you have a way of getting that value out. I've rounded it to 3 significant figures. I'm just going to pop in a wiggly equal sign to show it's an approximate answer. Right, next one, same process. I'm going to do the fraction times the area of the circle. So 250 out of 360 times pi r squared, which is going to be pi times 25. Okay, 5 squared is 25. So I'm going to write that as 25 pi. So now I'm going to think about simplifying. Both can be divided by 10, but that's as far as I can go. So I've got 25 out of 36 times 25 pi over 1. Now, in this example, there's no cross-simplifying I can do. So I'm just going to have to go ahead and work out 25 times 25. That's something that shouldn't scare you too much. Yes, it'll take a minute, but you can work through a process that will get you the answer. You actually get out 625 for that, pi over 36. There's no simplifying I can do, and I can guarantee that if I'm really careful to think about cross-simplifying before I begin. Okay, now 625 pi over 36, it's centimetres squared because it's an area, and that comes out as approximately 54.5 centimetres squared. Okay, one more example together, then I'm going to give you some to do on your own. So for this one here, I've got 23 degrees, so it's 23 over 360, and then the area is pi r squared. 4 squared is 16, so 16 pi, and I'm going to write it as over 1. I can't simplify this down at all, so I'm just going to be looking at this and thinking what I can do with it. I notice that the 16 and the 360 are both even, so I can half them. I can actually half it, and half it again, or in other words, divide it by 8. 16 divided by 8 is 2. 360 divided by 8 is 45. So we're then doing 23 over 45 times 2 pi over 1. 23 times 2 pi is 46 pi, and 45 times 1 is 45. So 46 pi over 45 centimetres squared. And if we had a calculator, we could then go to that and we could get the answer of 3.21 centimetres squared to 3 significant figures. Okay, so those are 3 examples for you. I'm now going to give you a few questions to have a little go at. Same principle, think about the fraction, think about the area of the whole circle, times them together, and if you can, try and do your cross simplifying like I've got here and get as far as you can before going to the calculator, because that's preparing you for seeing it in a non-calculator paper. Okay, here are some questions for you to have a go at. So have a go first of all at finding the area of these 3 where I've given you the picture, and then once you've done that, I've told you the radius and the angle theta. Okay, so I'm going to go through these answers now. So for the first one, we should be doing 20 over 360 times pi times 3 squared, or 9 pi. If you wrote that down in an exam, you would get a mark. If I simplify the first fraction, I'm going to get 1 over 18 times 9 pi over 1. The 18 and the 9 can be cancelled. That becomes a 1. That becomes a 2. So I end up with half a pi centimetres squared, and to 3 decimal places, that comes out as 1.57 centimetres squared. Okay, second question. I've got 120 degrees out of 360. That simplifies down to 1/3 times 8 squared times pi, or 64 pi, which is 64 pi over 3. And that simplifies, to 3 significant figures is 67.0 centimetres squared. Okay. Next one. Okay, for this one here, I've got an angle of 15, so it's 15 over 360 times 100 pi. 15 over 360 simplifies down, sorry, let me find the answer where I've got it written, to 1 over 24. Okay, that then simplifies to 25 pi over 6, and the area rounded is 13.1 centimetres squared. So I'm going to put that over here so you can see it. Well done if you managed that one. Okay, next one. For question number 4, we're going to do 80 over 360 times 36 pi. Okay, we can cancel down the 80 over 360 to 8 over 36, and then we can divide both of them by 4, and we can get 2 over 9 times 36 pi. The 9 and the 36 cancel now. We can divide that by 9 and that by 9, and we end up with 8 pi. If you did that to 3 significant figures, you should have got 25.1 centimetres squared. Okay. Question number 5, I'm just going to tell you the answer to, and then we will have a look at the challenge in a little bit more detail. So for question number 5, you should have got 11 over 72 times 100 pi, and that should have come out as 1,100 pi over 72, which can be cancelled all the way down to 275 pi over 18, or approximately, so I'm running out of space here, 48.0 centimetres squared. Okay. Okay, so here's how to do the challenge question. So in the challenge question, we were told that the area was 750 pi, the angle is 300 degrees, and we are asked to find out what the radius is. I'm going to do this 2 methods. The first method is my favourite method. It's just thinking logically about what we know. The second method is substituting into the formula and solving. Okay, either method is fine. It's just whichever one you personally prefer. So, first method. I've been told I've got 300 degrees in my sector. So job number 1 is thinking about what fraction of the circle I've got. I have 300 degrees out of 360, and I can now start simplifying it. So 30 out of 36, both of them divided by 6, so I'm going to get 5/6. So 5/6 of the circle is 750 pi. So 5/6 of the circle is 750 pi. Now, if you want to, you can draw a little picture of this. Okay, if I split a circle up into 6 pieces, 5 of those pieces altogether make 750. So I can work out what 1/6 of the circle is by dividing by 5. Okay, so if I do 750 divided by 5, 5s into 7 go once, remainder 2, 5s into 25 go 5, 5s into nothing go nothing. Okay, so 1/6 of the circle has an area of 150 pi. So now I know what 1/6 of the circle is, what one of these is. I can multiply by 6, or I can add it to itself 6 times to get that the whole circle is that times 6. Okay, so 150 times 6, well, 100 times 6 is 600. 5 times 6 is 30, so 50 times 6 is 300. So the whole circle has to be 900 pi. Now, I know a formula for the area of a circle, which is pi r squared. So if I now say pi r squared is 900 pi, I can divide both sides by pi. R squared has to be 900. I then square root. So r is the square root of 900. In other words, I'm thinking what number times itself gets us 900? The answer is 30. And because we're working in centimetres, I'm going to say that r is 30 centimetres. And then if you had this in an exam and you had some time in your hands, it would be a really good idea to put that fact and that fact together going forwards again and check your answer comes out 750 pi, and then you know that you're right. The other method is substituting into the formula. So I'm going to show you this method as well. So I can say theta over 360 times pi r squared is the area. And I can then put in the facts that I know. So I know that I've got 300 there. I know I've got 750 pi there. I don't know what r is. So I can say 300 over 360 times pi r squared is 750 pi. And I can then start solving it. Now, personally, I would go first of all to look at the fraction and simplify it in this case because the numbers are quite big and I can definitely simplify them. That simplifies just like before down to 5/6. So I can say 5/6 of pi r squared is 750 pi. I can divide both sides by pi. So I can then say 5/6 of r squared, is 750. And then you can either times by 6 or you can divide by 5, whichever method works better for you. I personally am going to divide by 5 because I like my numbers to be smaller rather than bigger. When I divide both sides by 5, we're going to get r squared over 6 is 150. Now I need to times by 6. Okay, 150 times by 6 is 900. R comes out as 30 centimetres still. Okay, you will notice that both of those methods have the same numbers coming into them all the way through. The reason for that is that at the end of the day, you are doing the same thing, but some people find this way a bit easier to do. Other people find this way easier to do. So it's just whichever method you personally find makes more sense to you. I'd say a lot of people find this one makes more sense because you're thinking at each stage, you can understand what you found. So it's easier to stay on track with it. But if you're someone who's really keen on using algebra, then that's fine. You can use that one instead.